Hi everyone, welcome to lesson 7 of indefinite integrals for JEE Mains and Advanced 2022-2023. So here I am, Jeff Wellesley, here on behalf of ODA Class once again, here to conduct an amazing class. Alright, so if you have not yet downloaded our app, make sure that you can go to Google Play Store and download our ODA app now itself. Already our app is downloaded by close to 50 lakhs people, so you can download the app again. Alright, and one more important information for you, we have a booster course going on. Booster course is a 6-day program where 3 maths class and 3 science class will be there, and you will be given the support of a personal teacher. Personal teacher means a mentor teacher who will take care of all the doubts. You know that, right? Usually at school, once the school is over, teachers will not be responding to your queries. But here, we are solving that problem by giving you a personal teacher who will take your doubt even at night. Okay? Apart from that, daily homework will also be given, tests will happen, and along with that, you will be given the e-modules. E-modules means PDF format of whatever we teach. That will also be given free of cost to you along with this booster course. The price is just 29, 49 or 99 depending on which grade you are in. To check the price, you can go to the description box. In the description box, you will find a URL using which you can enroll for this amazing booster course. And you all know about me, right? Those who have watched my last 6 lessons, you know about me. This is about me. If you do not know anything about me, that means you have not watched the past 6 classes. Make sure that you go and watch that, then come and watch this session. Okay, all right, so let's go ahead and do this question. How many of you have completed this question? This question was given to you as homework. How many of you have completed? You can give me a comment in the comment box if you have already completed this question. Well and good, or else I am here to help you out. Okay, so the question is integral x dx divided by root of 1 plus x square plus root of 1 plus x square the whole cube. This is the question. So this can be written as integral of x dx whole divided by root of 1 plus x square, let it remain there, plus root of this 1 plus x square the whole cube. I am splitting it as 1 plus x square the whole square into 1 plus x square. You can write like this. No one will come and stop me from doing this, right? Yes sir, all of you are giving me a thumbs up on doing this, right? You can do this. Yeah, so that should be equal to integral of x dx whole divided by root of, this root is there throughout, okay, this root is there throughout again, so root of 1 plus x square plus, what is root of 1 plus x square the whole square? That will be again a 1 plus x square, right? Into root of 1 plus x square will remain the same. I hope it is clear to everyone. This will be root of 1 plus x square, correct? So in this again you can write it as x dx divided by, what can you take common in these two? You can take it as root of 1 plus x square into 1 plus root of 1 plus x square, right? Fairly you can write it like this. Yes or no? So that is equal to, what can you do with this? This will be integral of, integral of x dx divided by root of 1 plus x square, let it be there, root of 1 plus x square into root of 1 plus root of 1 plus x square. You can fairly write it like this. Yes or no? You can write it like this. When you open the bracket, it's going to be the same thing as here, right? You can easily write it like this. So that should be equal to, now what can you do? Now think very carefully and check which part is having anemia so that you can give it some put. That means where to do the substitution. You can think which part needs some put, which part needs some food here. Yeah, which part? Anyone? You can give me an answer in the comment box here. What should be the substitution here in this? It might look complicated. No, but when you put the right substitution, this is going to be very, very easy. Easy peasy lemon squeezy. This is going to be. Okay. So what can we do here? Let's do one thing. Let's put 1 plus root of 1 plus x square as a t. Let's put this as a t, okay? What that is, this part, whatever is inside this root, you are putting it as a t. That is 1 plus root of 1 plus x square, you will put it as a t. So when you differentiate it, what happens? Derivative of 1 is 0, derivative of root is 1 by 2 root of 1 plus x square. Are we done it? No. Into derivative of 1 plus x square, which is 2x. 2 and 2 cancels. You will get x dx divided by root of 1 plus x square as a dt. Is this clear to all of you? So this is x dx divided by root of 1 plus x square as a dt. Is this much part clear to everyone? So x dx divided by root of 1 plus x square. Do we have it here? Yes. You have it directly written it here. Yes or no? Yes. Very clearly it is written here. X dx divided by root of 1 plus x square. That is what? X dx divided by root of 1 plus x square is dt divided by, now 1 plus root of 1 plus x square is t. So it will be root t. Is this clear? So this will be integral dt divided by root t, which is integral of t raised to minus 1 by 2 dt. What is integral of t raised to minus 1 by 2? You know that t raised to minus 1 by 2 integral will be t raised to 1 by 2 whole divided by 1 by 2, which is 2t raised to 1 by 2 plus c. That is 2 times of, what was your t actually? That is 2 times of 1 plus root of 1 plus x square. That is t raised to 1 by 2 plus c. This should be the final answer. Is it clear to all of you? Very simple question this has changed to. Okay, so it's perfectly fine if you did not get the answer, but try to observe it and try to, get the answer to this question. These similar questions have come in JEE mains in the past. Okay, this is a mains level question. So this is 2 into 1 plus root of 1 plus x square whole raised to 1 by 2 plus c. That's the question. Now let's move on to the next question, which is 2x plus 3 divided by root of x square plus 1. I'll do one thing. You can complete this particular question. You can complete it as a homework. I'll give you the hint on what to do. Split it as 2 parts. Okay. Integral of 2x divided by root of x square plus 1 plus 3 divided by root of x square plus 1. Okay, sir. Then what do I do? Yeah. Which part should I put? Whichever you think correct, you can put. I'm not giving the hint today because I don't believe in spoon feeding every question. Now it's slowly the time for you to think carefully, because I've already done similar questions. Think and come to a logical conclusion on what can be put the substitution here. Is it clear? Yeah. Fair enough. If this is clear, let's move on to the next question, which is integral of sec raised to 4x divided by root of tan x. You know that sec raised to 4x, can I write it as sec square x into sec square x? You can write it like this, divided by root of tan x dx. You can easily write it like this. Now you know that sec square x minus tan square x is 1, right? All of you know that sec square x minus tan square x is 1. So the first sec square x, total 2 sec square x is there. Out of that, just the first sec square x, I am writing it as, since sec square x minus tan square x is 1, sec square x can be written as 1 plus tan square x, right? So sec square x is 1 plus tan square x. Into this sec square x, let it be there, dx divided by root of tan x. Is this part clear to all of you? Now what do we do? What is the most suitable substitution here? Tan and sec are derivative, right? Tan derivative is sec square x, right? So what will we do? You can do one thing. Let's give some putter to tan. So tan x is equal to t. Clear? So tan x is equal to t. Clear? All are clear with it? Yeah. So if tan x is equal to t, when you differentiate, what do you get? Sec square x dx is equal to dt. Yes, sir. Bingo. You have a sec square x dx here. Correct? So this is equal to integral of 1 plus tan square, which is 1 plus t square, into sec square x dx is dt whole divided by root of t. This question changes to a very simple integral like this. Correct? So you can write this as equal to integral of 1 by root t, which is t raised to minus 1 by 2, right? 1 by root t is t raised to minus 1 by 2, plus t square divided by root t is t raised to 3 by 2, right? dt. This will be the question then. Integral of t raised to minus 1 by 2 plus t raised to 3 by 2 dt. This is the question. So what is integral of t raised to minus 1 by 2? It should be t raised to 1 by 2 divided by 1 by 2 plus integral of t raised to 3 by 2 will be t raised to 5 by 2 divided by 5 by 2 plus c should be the answer. Yes or no? So that is 2t raised to 1 by 2 plus 2 by 5 times of t raised to 5 by 2 plus c. So that is equal to 2 times of, what is your t here? What is your t here? T value is tan x. T value is tan x. So this is tan x whole raised to 1 by 2 plus 2 by 5 times of tan x whole raised to 5 by 2 plus c. This should be the final answer for you. Yes or no? So this is 2 times of tan x raised to 1 by 2 plus 2 by 5 times of tan x raised to 5 by 2 plus what is there? Very important. Constant of integration, that is c, should be there. Right? Fair enough. Then everyone think how you can do this particular question. Integral of sine cube x divided by cube root of cos square x dx. Whenever you have sine and cos, what should you think about it? Whenever there is, sine and cos, you should understand that sine and cos are derivatives of each other, right? Sine and cos are fairly derivatives of each other. So what can we do over here? What can we do over here? Yeah, this sine cube x, let me write it as sine square x into sine x. Okay, and the dx will remain divided by cube root of cos square x. You can write it like this. Yeah, so that is equal to integral of, can I say sine square x minus sine square x plus cos square x is 1, right? So sine square x, can I write it as 1 minus cos square x? So the sine square x on top, you're writing it as 1 minus cos square x into sine x divided by cube root of cos square x. You can write it like this. Yes. Now what can you do further? What should be the substitution here? Okay, sir, let me think, sir. Let me think. Sir, I think sin x should be the substitution, sir. Cos is there. But I think let's try with cos x as the substitution. Okay. Okay, sir. Let's, whatever you say, sir, that should be the answer, right? Yeah. So let's say cos x. Let's give some put to cos x. Okay. So put cos x as a t. When you put cos x as a t, what will happen? What is the derivative of cos? Minus sin x. So you'll get minus sin x dx as a dt. So that means sin x dx will be minus dt here. Is this part clear to all of you? So sin x dx will be minus dt. So this question, can I change it as 1 minus cos square x, which is 1 minus t square, into sin x dx is minus dt whole divided by cube root of cos square x, that is cube root of t square, right? So cube root of t square, cube root is raised to 1 by 3, right? Cube root is raised to 1 by 3. So it will become 2 by 3. T raised to 2 by 3. Can I write it like this? Because t is cos x, t raised to 2 by 3. Correct or not? Cube root means raised to 1 by 3. So let's write it further as, okay, so what do you have? Minus, this minus of 1 minus t square. Let me write it here itself. So this is minus of 1 minus t square is t square minus 1 divided by t raised to 2 by 3 dt. This is the question right in front of you. Yes. So this question can be changed as t square divided by t raised to 2 by 3, which is t raised to 2 minus 2 by 3. Right. So t raised to 2 minus 2 by 3 minus 1 by 2 raised to t raised to 2 by 3. So it is minus 1 by, what is there here? Minus 1 by t raised to 2 by 3. And dt. This is what we have, correct? Did we make any mistake here? I think all good. T raised to 2 minus 2 by 3 minus 1 by t raised to 2 by 3, right? Yeah. So that is t raised to, 6 minus 2 by 3, which is 4 by 3, correct? Minus t raised to minus 2 by 3 dt. This is the question in front of you, right? So what is the integral of t raised to 4 by 3? It should be t raised to 4 by 3 plus 1, which is 7 by 3 divided by 7 by 3, which is 3 by 7 times of t raised to 7 by 3 minus t raised to minus 2 by 3 plus 1, which is t raised to 1 by 3 divided by 1 by 3, which is t 3 raised to 1 by 3 plus c. Correct? That is equal to 3 by 7 times of, what is your t here? What is your t here? T value is cos x, right? T value is cos x. So it is cos x raised to 7 by 3 minus 3 times of cos x raised to 1 by 3 plus c, this has to be the answer. Yes, so 3 by 7 times of cos x raised to say 1 by 3 minus 3 times of cos x raised to 1 by 3 plus c should be the final answer here. All are agreeing to it? Okay sir, whatever you say, that should be the answer, right? Yeah. Now think carefully and try to do this particular question then. What is the integral of, dx divided by cos cube x into sine 2x, root of sine 2x. There is a root of sine 2x here. So how can we handle this particular question, my dear friends? So let's think carefully, okay? So this is equal to integral of, what can we do here? Dx divided 1 by cos cube x, can I write it as c cube x, right? 1 by cos cube x is c cube x, right? So it is c cube x dx divided by sine 2x is root of 2 tan x divided by 1 plus tan square x. Is it clear? 2 tan x divided by 1 plus tan square x. Correct or not? Sine 2x, one of the expansion of sine 2x. One of them is 2 sin x cos x, other one is 2 tan x divided by 1 plus tan square x, right? Fairly you can write it like this. Now what can we do further? This can be written as integral of c cube x divided by root 2 tan x divided by root of 1 plus tan square x. What is 1 plus tan square x? What is 1 plus tan square x? Yes sir, I know, I know. What is it? Yes sir, it is 6 square x, right? 1 plus tan square x is 6 square x. So root of sec square x will be sec x. So when sec x is there in the denominator, that will go to the numerator, right? So it will become c cube x into sec x dx. Is this clear? So root of 2 tan x divided by root of 1 plus tan square x. Okay, root of 1 plus tan square x is sec square x. Root of sec square x which is sec x, which goes to the numerator. So this is changed to integral of sec raised to 4x, right? Because sec cube x into sec x is sec raised to 4x dx whole divided by root 2 tan x. Can I write it like this? So how will we integrate integral of sec raised to 4x divided by root 2 tan x? How can we do this question? Let's think. How can we do it, my dear friends? Yeah, we have done a similar question already. How many of you remember? Today itself. Did we not? Yes, we have done it, sir. How did we do that? Do you remember? Let us split that sec raised to 4x into sec square x into sec square x. Can I change it like this? So this is sec square x into sec square x divided by root of 2 tan x dx, sir. Okay, sir. Clear? Now what can we do? Okay, so we can change sec square x into what? Sec square x minus tan square x is 1, right? Yes, sir. Then sec square x can be written as 1 plus tan square x, right? So 1 of the sec square x, let's change it to 1 plus tan square x, right? So there is 1 plus tan square x into sec square x divided by root 2 tan x and a dx. Fair enough? Can I change it like this? Is anyone stopping me now from doing this? I hope no. Then let's go ahead and solve this further. What do we do here again? Let's put tan x as a t. When you put tan x as a t here, okay, so let's put tan x as a t. If tan x is t, you know that sec square x dx has to be dt here, correct? Sec square x dx has to be dt here. So what does this question change to? This question was integral of 1 plus tan square x, which is 1 plus t square. Then what is left? Into sec square x dx, which is dt, divided by root of 2 tan x, which is root 2t. This is the question right now, isn't it, my dear friends? Yes, sir. Yes, sir. This is the question. Now, how do I integrate? I've done so many questions, but still I do not remember, sir. It's time you start remembering, my dear friends. It is time you start doing this question now. What will be the answer here? This will be integral of 1 by root 2. Let's take it outside completely. Okay. So 1 by root 2 times of 1 divided by root t, which is t raised to minus 1 by 2, plus t square divided by root t again. T square divided by root t will be t raised to 2 minus 1 by 2, t raised to 3 by 2. Yes, dt, sir. This should be the answer. Again, let's integrate it further. So this should be 1 by root 2 times of, 1 by root 2 times of what, sir? Integral of t raised to minus 1 by 2. What is integral of t raised to minus 1 by 2? You know that integral of t raised to minus 1 by 2 is t raised to 1 by 2 divided by 1 by 2. Yes, so t raised to 1 by 2 divided by 1 by 2. Further what do we have? Plus t raised to 3 by 2 integral will be t raised to 5 by 2 divided by 5 by 2. Plus c, and 1 by root 2 is there for both the terms. Don't forget about that. 1 by root 2 is there for both the terms here. Yes? Yes, sir. So this is 1 by root 2 times of, this 2 should go to the numerator, so 2t raised to 1 by 2 plus 2 by 5 times of t raised to 5 by 2 plus c. Correct or not? This is what we have. So that is equal to root 2 times of t raised to 1 by 2. Root 2 times of t raised to 1 by 2. What is t actually? Tan x raised to 1 by 2. Right? Root 2 times of tan x raised to 1 by 2. Then what will happen? Again this 1 by root 2 is still there. So root 2 divided by 5 times of, root 2 divided by 5 times of tan x raised to 5 by 2, sir. Yes. Plus c you will get as the answer, sir. Yes or no? This should be the final answer now, right? Very simple then. Yeah. So root 2 times of tan x raised to 1 by 2 plus root 2 divided by 5 times of tan x raised to 5 by 2 plus c is the answer, sir. All good, my dear sirs. And madam, listen dear. Everyone fine with it? Yes? Alright, that's great. Then let's go ahead and solve this particular question. This is a very interesting question again. What is the integral of e raised to log of 1 plus 1 by x square divided by x square plus 1 by x square? How will we solve this? Now, what is e raised to log f of x? All of you know that e raised to log f of x is f of x, right? So e raised to log of 1 plus 1 by x square is 1 plus 1 by x square divided by x square plus 1 by x square dx. Now observe very carefully. So very carefully. Yeah. Are you able to find something here? Can you find a function and its derivative directly here? Okay. Keep observing. You will not find it directly here. That is the hard truth. So what can we do here to manipulate this thing and convert it into forms which are integrable? That is the next headache in front of you. Let's check. We'll find out. So 1 plus 1 by x square is there in the numerator, and in the denominator there is x square plus 1 by x square, right? Can I say x square plus 1 by x square is x minus 1 by x the whole square? What is x minus 1 by x the whole square? Sir, I remember I learned something called identity somewhere. I don't remember. Oh, sir, yes, it is x square plus 1 by x square minus 2. Because there is minus 2 here. So to compensate for that, we will add a plus 2 here. Clear? Is it clear to everyone? Now can you see a function and its derivative here right now? How many of you can see a function and its derivative here now? Yes, sir. I think there is a function and a derivative here. What is that? Okay. So let's put x minus 1 by x. Let's put it as t. Now what is the derivative of x? You know it is 1. And derivative of minus 1 by x will be plus 1 by x square, right? Because minus and minus cancels. It will become plus 1 by x square. 1 by x derivative is minus 1 by x square. Minus and minus together cancels and becomes plus. So 1 plus 1 by x square dx will be dt, sir. So this question can further be written as 1 plus 1 by x square dx is dt divided by t square plus 2. Can I write this 2 as a root 2 whole square also, sir? Easily you can write, sir. Yeah, because this 2 can be written as root 2 the whole square now. So this question is integral dt divided by t square plus root of 2 the whole square. What is integral 1 divided by x square plus a square? Those who do not know, integral 1 divided by, okay, integral of 1 divided by x square plus a square dx is 1 by a tan inverse of x by a. plus c. Okay, it is 1 by a tan inverse of x by a plus c. So what will be integral of dt divided by t square plus root 2 the whole square? It is 1 by root 2 because a is root 2. 1 by root 2 tan inverse of, what is x? Instead of x there is t, divided by root 2 plus c, sir. That is 1 by root 2 times of tan inverse of, what is your t here? Yes, t value here is, what was our t? X minus 1 by x, sir. So it will be x minus 1 by x whole divided by, this is x minus 1 by x whole divided by root 2, which will remain there, plus c should be the answer. So 1 by root 2 times of tan inverse of x minus 1 by x whole divided by root 2 plus c, sir. That should be the answer, sir. Yes? Clear to everyone? This is a good question. This type of manipulation you are seeing for the first time. So anytime when you have combinations like this, think on this behalf, whether you can complete the square, can write it in such a form. Check whether you can do it. That will be helpful. Okay? Now let's do one more interesting question. The question is integral of f of x into g dash of x minus g of x into f dash of x divided by f of x into g of x dx divided by into log of g of x into f of x. Okay, dx. That's the question. Okay, one dx is there. Yeah, that's the question. How many of you are seeing stars already by seeing this question? Are you able to find a function and its derivative already? Let's check whether it's possible here. Okay, whenever by seeing a question you are getting a headache, that shows there should be some small trick. Once you apply that, you will get the answer. Okay, so don't be scared by very complicated terms like this. It is going to make your life easy only. Okay, so let's think what substitution you can fairly make here. Let's do the substitution. Let's put log of g of x by f of x. Let us put it as a t. You know that log of g of x by f of x is log of g of x minus log of f of x, right? You can write it like this. Let's put it as a t. So log of g of x minus log of f of x is t. So what is derivative of log of g of x? It should be 1 divided by g of x into derivative of g of x, which is g dash of x, minus 1 divided by f of x into derivative of f of x, which is f dash of x, dx will be dt from this. Is this clear to all of you? Yes, taking the LCM you can write g dash of x into f of x minus f dash of x into g of x, right? F dash of x into g of x divided by f of x into g of x dx will be our dt, sir. Yes, this will be our dt. Do you see this? F of x into g dash of x minus g of x into f dash of x divided by f of x into g of x, right? What is that? You can easily put that as a dt, sir. Yes, let's put it as a dt now, my dear friends. So this will be equal to integral of dt into log of g of x by f of x is, sir, that is a t, sir, already. So let's put it as a t. So integral of dt into t, that is same as integral t dt, right? What is integral t dt? Very simple, sir. First day itself, sir taught you what is integral t dt. It should be t square divided by 2 plus c. So this should be t square divided by 2 plus c, sir. What is our t, sir? T is something made of milk and tea powder. No, our t here is log of g of x by f of x. So log of g of x divided by f of x, that's our t. So that one, the whole square divided by 2 plus c will be the answer. So log of g of x by f of x, the whole square divided by 2 plus c is the final answer, sir, here. Now isn't it very simple now? I told you, when you see complicated things like this, always remember this is going to be a very easy question. Just they are putting it to confuse you. Okay, fair enough. Now let's move on to the next type of question, that is integral of 3x raised to 4 minus 1 divided by x power 4 plus x plus 1 the whole square. Yes sir, I will put the function as x raised to 4 plus x plus 1, sir. Then the derivative should be 4x cube. But on top, do you have a 4x cube? No sir, I do not have it, sir. So what do we do in this kind of a question? That is the trouble here. How many of you can think of some sort of a solution to this? Integral of 3x raised to 4 minus 1 divided by x raised to 4 plus x plus 1 the whole square. How can you integrate this question? Yes? If you can, just give an answer in the comment box, my dear friends. What can we do here? Let's do one thing. This can be written as integral of 3x raised to 4 minus 1 whole divided by, in x raised to 4 plus x plus 1, I am taking an x outside, okay. So if I take an x outside, what does it become? This will be x into x cube plus 1 by x, right? And this complete thing will have the square, right? So here I am taking the x outside, so this is x into x cube plus 1 by x, the whole square. Sir, you are making this very complicated. No, my dear friends, let's think. So this x, the whole square, I am taking it outside, okay. So this can be written as integral of 3x raised to 4 minus 1 whole divided by x square is outside into x cube plus 1 by x, the whole square, sir. You can write it like this also. Yes, no one will come and stop you. No, don't do it. No one will say that, right? So you can say like this, right? So what can we do further? This can be written as, let's divide this 3x power 4 minus 1 by x square. So what does it become? This will become integral of 3x square minus, you know, what is left? Minus 1 by x square. Okay, sir. Minus 1 by x square whole divided by x cube plus 1 by x, the whole square, dx. Yes, sir, this looks okay. Now let's think what can be substituted here to find the function and its derivative. Check. What can be substituted here? Think, the denominator can be substituted, right? What is there in the denominator? Let's give some put to x cube plus 1 by x. Let's put it as a t. If I put x cube plus 1 by x as a t, what is the derivative of x cube? You know that the derivative of x cube is 3x square. Plus derivative of 1 is 0. Derivative of 1 by x is minus 1 by x square. Dx. This should be dt. Is this clear to all of you? This should be dt. Correct? So it is 3x square minus 1 by x square. Dx is dt. Do you see that right on top? Right on the denominator, are you able to find that? Yes, sir. I am able to find that, sir. So this should be integral 3x square minus 1 by x square dx. I can easily put this as a t, sir, or a dt, sir, dt. So this is dt. So this will change to integral of, let's change it to integral of dt divided by t the whole square, because x cube plus 1 by x is t. So this can be written as t square. So which is equal to integral of t raised to minus 2, which will be t raised to minus 1 divided by minus 1, which is minus t raised to minus 1 plus c, sir. This is minus 1 by t plus c, sir. This is minus 1 divided by, what was our t, sir? What was our t, sir? T was x cube plus 1 by x. So it is x cube plus 1 by x. Right? Plus c should be the answer, sir. This is clear to all of you. So the final answer will be minus 1 divided by x cube plus 1 by x plus c has to be the final answer here in this particular question, my dear young friends present here. Yes? Yeah. Now, in the next class, I am giving you the homework for the next class. Very similar question, but not the exact same question. The substitution and what you take outside from the denominator will be slightly different here. So try to solve this question. The question is integral 3x raised to 4 plus 4x cubed divided by x raised to 4 plus x plus 1 the whole square. Similarly, one very similar question. This is also of the same type, integral 5x raised to 4 plus 4x raised to 5 divided by x power 5 plus x plus 1 the whole square. So try to decode these two questions and try to solve it. I'll come ahead in the next class and definitely be solving it. Okay. So it was wonderful teaching you all as usual. So stay tuned to our ODA channel. Make sure that you download our app, ODA app, right now itself, because a lot of free classes keep on running in our ODA Class app, that is our open sessions keep on running. And apart from that, we also have a booster course. Okay, booster course is a 6-day program where 3 math class and 3 science classes are there, and you will be given the support of a personal teacher also, and daily homework will be given, test series will happen, and also the ebook, that means a PDF of whatever we teach also will be given free of cost to you. So don't miss this opportunity. The price is 29, 49 or 99 depending on which grade currently you are studying in. Fair enough? Now for enrolling, you can go to the description box. You will find the URL for enrolling. You can press on that, and now itself you can enroll for our amazing booster course. Okay, so don't miss this opportunity. And those who are downloading our app, they'll be given free ODA coins, which can be used for getting smartwatch, smart speakers, smart mobile, Amazon gift coupons, etc, etc. Alright, so it was wonderful teaching you as usual. Don't forget to like, share and subscribe to our YouTube channel and share it with all your friends. We will meet again. Until then, bye bye. Have a nice time. Complete your homework. Bye bye.